In this video, I'm going to remind you about geometric sequences. A geometric sequence is a list of numbers or images that changes by multiplying by the same amount at each step. In my two examples, I'm going to show you one that is a geometric sequence and one that appears to be but really is not. So the first one, the one that is a geometric sequence, is so because when we go from a 5 to a 10, we are multiplying by 2. 5 times 2 is 10. To go from a 10 to a 20, we're also multiplying by 2. And then from a 20 to a 40, again multiplying by 2. So that one by definition is a geometric sequence. The lower one is not a geometric sequence. Whereas the numbers do appear to be growing by multiplication, we're not multiplying by the same amount at each step. So multiplying by 2, then by 3, then by 4, even though that's a pattern in and of itself, it is not a geometric sequence. Likewise, you can look at a picture pattern and determine if it is geometric. You'll go through the same process of studying the steps and seeing how they grow. In this case, the first picture, the first image of the first picture pattern has 3 dots in it. The second picture has 6 dots in it, and the third picture has 12 dots in it. These dots are growing by 2. They are doubling. Each picture is double what the first picture or the previous picture had in it. This one is a geometric sequence in terms of a picture pattern. The lower one is not. The first image has 1 box in it. The second image has 2 boxes. The third picture has 4 boxes, and the fourth picture has 9 boxes. Again, whereas it appears that maybe we're multiplying as the picture pattern grows, we're not multiplying by the same amount because 4 times 2 does not give you 9. So this one is not a geometric sequence picture pattern. Now you're likely going to be asked to do one of 3 things. Maybe generate a sequence, or find a common ratio in the sequence, or maybe find the next 3 terms in the sequence, and that's what I'm going to take care of in this video, just reminding you how to do those types of problems. So the first thing you might be asked to do is generate your own sequence. It's very simple. To do it, though, you have to know 2 key pieces of information. You're going to need to know what the starting value is and what number you're multiplying by each time. So in my first example, I'm saying generate a sequence that starts with -2 and grows at a rate of 3 times at each step. Well, if it starts with a -2, then I'm going to write a -2 at the beginning for my first number, and then to find the next number, I'm going to multiply by 3. Since -2 times 3 is a -6, I'm going to say the next term in my sequence is a -6. And then I'm going to continue that pattern of multiplying by 3, and I'm going to say the next term in my sequence is a -18. And I would continue that pattern of multiplying by -3, and I've just generated a sequence. You're going to do the same thing. I want you to generate the first 5 terms of a sequence that starts with 40 and decays by a half at each step. Now, if you think you know what to do, then just pause the video, go work it on a piece of paper, and then resume the video and check your work against mine. But if you're not quite sure how to start the problem, let me remind you. They told you what the starting number was in the sequence. They told you it was 40. And since it is decaying, what you need to think is that the numbers are going down. But since it's a geometric sequence, you know you're multiplying. So we're going to start with the number 40, and we're going to decay by a half, meaning we're going to multiply each step by 1/2 in order to get the next number in the list. So if you take 40 and multiply it by half, that's the same thing as saying half of 40, which is 20. So the second number in the list is 20. I want you to keep going. If you haven't done this already, find the next 3 terms. That would give you a total of 5. You're just halving at each step. So half of 20 is 10. Half of 10 is 5. And then half of 5 is 2.5. You can write 5 over 2 for your answer, or if you want, you can write 2.5. Doesn't really matter. Now, you might also be asked to find the common ratio in a geometric sequence. The common ratio is just that number that you are multiplying by to go from step to step. It's not very hard to find it. All you do is divide the second value in the sequence by the first value. Or you could do any two consecutive values, any two numbers that are right next to each other. That's what consecutive means, in order to find out what you're multiplying by. Some people are really intuitive and can do it quickly. Other people need a path. So this is what you do. In my example 3, I'm asked to find the common ratio in this sequence. I'm suggesting that you take the second term in the list, in this case 6, and divide it by the first term in the list, which is 24. 6 divided by 24, or if you thought of it more in terms of reducing a fraction, you would say 6 goes into itself one time, 6 goes into 24 4 times. Or I could say what I'm multiplying by, my common ratio would be 1/2. Sorry, 1/4. I'm assuming that's what my common ratio is, but I find it very important to check it. So I want you to take 6 and multiply it by 1/4 and see if you get 1.5. I'm going to do it on my calculator right now. 6 times 0.25, or I can say 6 divided by 4, since dividing by 4 is the same thing as multiplying by 1/4. And yes, I do get 1.5. I'm going to multiply by a fourth again, and I get 0.375. So I feel very confident, very comfortable that my common ratio is 1/4. Okay, now it's your turn again. I want you to do the same thing I just did. Find the common ratio in this sequence. Look at the list of numbers, see how they're growing. Again, sometimes you can do it intuitively. If you're not very good intuitively, then follow the plan. The plan is take the second number, divide it by the first number. It should give you your common ratio right off the bat. Pause the video, try it, test it, and see if you get what I get. 12 divided by 4 is 3, so I suspect that my sequence is growing by multiplying by 3. 4 times 3 is 12. Since I know that 12 times 3 is 36, and 36 times 3 is 108, I feel very confident that my common ratio is 3. Now something else you might be asked to do is to find the next term or terms in a sequence. To do that, you're going to need to know what the common ratio is. So if they give it to you, great, use it. If they don't give it to you, then you're going to have to find it first. So in this example, I've given you a list of 4 numbers to start with. I'm asking for the next 3 terms in the sequence. To get the next 3 terms, though, I'm going to need to know what I'm multiplying by. To find out what I'm multiplying by, remember we take the second number and divide it by the first number. So -5 divided by 1 is -5. It appears that we are multiplying by a -5. Check to make sure that that works. Is -5 times 5 25? Is 25 times a -5 equal to a -125? If that's the case, then you know that's what you're multiplying by. -125 times a -5, -125 times a -5, I'm on my calculator, is 625. To get the next term, keep multiplying by a -5. Times -5 is a -3,125. And then again, times -5 is big number, 15,625. Okay, your turn again. Find the next 3 terms in the sequence. I've given you 4 numbers to start with. You need to find the common ratio and then the next 3 terms. Pause the video, have at it on your separate sheet of paper, and then check your work against mine. Here I go. The second number divided by the first number. -8 divided by -2. Since -8 divided by 2 is 4, it makes me think we're multiplying by 4 as we go down our table or up our list or across our list. I'm going to test it though just to be sure. -8 times 4 is a -32. Times 4 is a -128. I'm going to keep multiplying by 4. -128, I'm laughing because my husband's cell phone is ringing, and listen to that ringtone. Oh, -512 times 4 is negative 2,048. And then last one times 4 is negative 8,192. Okay, now for finding the next term in a picture pattern. It's really kind of easy because a lot of times you can just look at the picture and just follow the pattern and not even think about the math behind it. But naturally, I am going to want you to think of the math behind it. If you know it is a geometric sequence, and actually you can kind of tell on your own, remember this is the example I did at the beginning. The first step had 3 dots in it, the second step had 6 dots in it, and the third step had 3 times 4, 12 dots in it. If you look at these numbers from 3 to 6, we're changing or multiplying by 2. To go from a 6 to a 12, we're multiplying by 2. So that means to go to the next picture, multiplying by 2 again, I should end up with a picture that has 24 dots in it. So how's that going to look? Well, I'm going to try to follow the pattern that I see in the picture. I see 3 groups of dots in each case, and I know my dots are doubling. So I'm going to take this first section, and I'm going to double that. Instead of having 4 dots, I'm going to have 8 dots. Does that look okay? And then this one will also have 8 dots. 4, 5, 6, 7, 8. And this one, 8 dots. 1, 2, 3, 4, 5, 6, 7, 8. That's what I think the fourth step would look like. 3 dots of 8, or total of 24 dots. Okay, now you try. Take the picture pattern. I've given you 3 steps of the picture pattern. You know it's geometric, or you suspect it's geometric. I want you to sketch the next image. Pause the video, sketch it, and then when you're done, test it and see if it looks like mine. I'm looking at step 1, I see 1 triangle. I look at step 2 and I see 2 triangles. I look at step 3 and I see 4 triangles. It appears that these triangles are growing, or the image is growing by doubling, times 2. So that means the next picture should have 8 triangles, right? So maybe your picture looks something like this. Here's my 4. That looks like step 3, but if I put another 4 on there, like in other words, if I double it, does your picture look something like that? Hope so. That's what step 4 would look like. So just to recap, this is what we went over in this video. That geometric sequences are generated by multiplication. You multiply the same number to go from step to step. The number that you multiply by is called the common ratio. It's often referred to by the letter R. And in order to find the common ratio, you're going to divide any 2 consecutive terms, that's any 2 numbers that are right next to each other in the sequence, and then test that number to make sure it works. Sometimes you're multiplying by a whole number, sometimes you're multiplying by a fraction. If you're multiplying by a whole number, the sequence is getting larger, and if you're multiplying by a fraction, the sequence is getting smaller, or the numbers in the sequence are getting smaller. So there you have it. Now you know about geometric sequences. Good luck!